Hi everyone, let's learn about set operations. The union is all elements in any set, and the intersection is what's shared.
Good morning, everyone. Today we are going to learn about set operations. Have you ever wondered how we can combine groups of objects in mathematics? For example, how we can find what two groups have in common or what makes them different? That's exactly what set operations help us do. By the end of this lesson, you will understand how to combine, compare, and analyze sets in a clear and logical way. So, let's get started.
First, let's talk about the definition. Set operations are mathematical processes used to combine, compare, or modify sets in order to produce a new set based on specific rules. In simple words, we take one or more sets, apply a rule, and create a new set. These operations help us understand the relationships between sets and their elements. So instead of just listing numbers or objects, we can analyze how they are connected. This is very important in mathematics, logic, and even computer science.
Now let's look at the main types of set operations. There are four important ones. First, union, represented by the symbol U. Union combines all elements from both sets. Second, intersection, represented by the symbol N. Intersection includes only the elements that both sets have in common. Third, complement, written as A complement or A prime. This means the elements that are not in set A. And finally, difference, shown with a minus sign. Difference means the elements that are in one set but not in the other. These four operations form the foundation of set theory.
Today, I will present the union of sets. The union of set A and B is the set of all elements from both sets. We use the symbol U. For example, if set A is 1, 2, 3, and set B is 3, 4, 5, the union of A and B is 1, 2, 3, 4, and 5. Remember, we do not write duplicate members.
Intersection. The intersection of two sets is the set of elements that are common to both sets. It is written as A intersection B or A in like mound B. This means we only choose the elements that appear in both sets at the same time. There are some important properties of intersection. First, the commutative property. A intersection B is equal to B intersection A. Second, the associative property. A intersection B intersection C is equal to A intersection B intersection C. Third, the identity law. A intersection U equals A, where U is the universal set. And fourth, the domination law. A intersection empty set equals empty set. So intersection means keeping only the elements that both sets share. Now, let's look at an example. Let's set A be the numbers 1, 2, 3, and 4, and let set B be the numbers 3, 4, 5, and 6. If we want to find A intersection B, we look for the numbers that appear in both sets. We can see that the numbers 3 and 4 are in both set A and set B. So the intersection of A and B is the set containing the numbers 3 and 4. This means A intersection B equals the set 3, 4. And that's how we find the intersection of two sets. The complement of a set. The complement of set A is written as A complement, A superscript C, or A prime. The complement of a set A is the set of all elements in the universal set that are not in A. In other words, it is everything inside the universal set except the elements of A. We use this formula. A prime equals U minus A. A prime equals U minus A. This means we remove the elements of A from the universal set. Let's look at an example. Let U equal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and A equals 2, 4, 6, 8, 10. To find A prime, we remove the elements of A from U. The remaining elements are 1, 3, 5, 7, 9. Therefore, A prime equals 1, 3, 5, 7, 9. To conclude, the complement of a set includes all elements in the universal set that are not in the given set. Always remember, A prime equals U minus A.
The difference between set A and set B, written as A minus B, is the set of all elements that are in A but not in B. Simply put, it is A minus the parts it shares with B. Imagine we have set A, which contains the numbers 1, 2, 3, and 4, and we have set B, which contains the numbers 3, 4, 5, and 6. If we want to find A minus B, we start with the elements in A. Then we look at B and see that they share the numbers 3 and 4. So we remove those from our group. This means our final result for A minus B is simply the set containing 1 and 2. And that's how you find the difference between two sets.
All right, everyone, that brings us to the end of our presentation on set operations. We hope you now have a clearer understanding of how union, intersection, complement, and difference help us analyze relationships between sets. Mathematics is not just about numbers, it's about understanding patterns and connections, and set operations are one of the tools that make this possible. Thank you so much for your attention and participation today. If you have any questions, we would be happy to answer them. Thank you.